Hello everyone. In this example we're going to be taking a look at determining sample size and determining confidence level when working with a population proportion. And just as a quick reminder, this is how we form a confidence interval in general. We use our sample statistic and then we add or subtract our margin of error. Our margin of error is based on our critical value, that's our z-star value, and then we multiply that by the standard deviation of the statistic. Sometimes this is referred to as a standard error. So let's take a look at the first example. So here we want to randomly select employers to contact about, do you plan to hire additional employees in the next 60 days? We want to have a 98% confidence interval and we want our margin of error to be no more than 5%. So our question is, what do we need to have for our sample size in order for these conditions here to be met? So a 98% confidence interval, you'd want to look up the z-star value. And if you remember, I said that's on the table B. I'm going to pause this and get table B. So here we have table B, and we can see that our z-star value for a 98% confidence interval is 2.326. So let me write that down. Our z-star value is 2.326. And we want this to be no more than 5%, so our margin of error is going to be less than or equal to 5%. And now I need to figure out what to put down for p hat and 1 minus p hat in our formula. In other words, I'm substituting in numbers that I know here that is then going to allow us to solve for n. So what number should I put in for p hat? Well, if we have a previous study, we might use numbers from a previous study. But if we don't have a previous study, then we have to ask ourselves, what's the largest value we could possibly have for the product of p hat times 1 minus p hat? In other words, what product here would make this as large as possible so that we can sample as many as we need to and be kind of conservative or cautious here? So if I think about all the different pairings of possible values for p hat along with possible values for 1 minus p hat and take a look at each of these products, I can see that the largest product is going to be when p hat is 0.5, because this would give us 0.25 versus 0.16 or 0.09. So I'm going to use 0.5 times 1 minus 0.5, which is also 0.5. So if you have no idea what to use for p hat because you haven't done a previous study, you can just use 0.5 to be conservative. And at this point, I think you guys know how to do the algebra. At least I would hope that you would know how to do the algebra. The square root of 0.5 times 0.5 is just 0.5. We still have the square root of n in the denominator. And then I am going to multiply 2.326 times 0.5. And keep solving for n. And so then I have, let's see, when I divide by 0.05 and multiply by the square root of n, I end up having 23.26 less than or equal to the square root of n. And when we square both sides, I get that n has to be greater than or equal to 541.0276. We'll just say 0.03. So how many people do I need to survey? Do I need to survey 541 or 542? Well, because we want to make sure our margin of error is at least 5%, then we need to, or no more, I should say, no more than 5%, then we need to make sure we sample at least 542. In other words, if I sample more people, I know my margin of error is going to be smaller. The more people I sample, the smaller the margin of error. Because the more people we sample, the larger our denominator becomes, the smaller this entire fraction becomes, the smaller our margin of error becomes. I'll say that again. The more people we sample, the smaller our standard deviation of our statistic, and the smaller our margin of error. So here, to answer this question, we need to sample at a minimum 542. If we sample more than 542 businesses, then we'll actually have a smaller margin of error. Let's take a look at determining confidence level. Here we have a newspaper reporting that the governor's approval rating is at 65%. The article adds that the poll is based on a random sample of 972 adults, so that's our N, that's our sample size, and the margin of error is 2.5%, so 0.025. The question is, what level of confidence did the pollsters use? So remember, our formula for margin of error is our z star value times the square root of p hat times 1 minus p hat all over n. So I'm going to substitute in what I know here. I know my margin of error, that's 0.025. I don't know my z star value because that's related to the confidence level, which I'm trying to figure out. So I'll just leave that there. P hat is this 65% that they got from their poll. So 1 minus p hat would be 35%. And my sample size is 972. So I'm pretty sure you guys could solve this for z by taking the square root of this calculation and then doing 0.025 and dividing by that. When you do that calculation, you get z star is equal to 1.634. So let's go back to our table. Let me see if I can find it here. Here we go. 1.634, it's not quite on the table here, but it looks like it's pretty close to this 1.645 number. It probably was a 90% confidence interval because I'm guessing that this 65% was a rounded 65%, and this margin of error was also rounded. So I'm going to say that this was a 90% confidence level. We'll be going over examples like this in class on Thursday, and tomorrow, because I have a feeling we're going to have a snow day, tomorrow we're going to have a video for you to watch. I'm going to make that at home. It is going to be an old AP free response problem for you guys to take a look at.